are your physics teacher for today's lesson. I am Teacher Nova.
And I am Teacher Berna, and our lesson for today is about fluid mechanics focusing on buoyancy. But before we start our class, may I call on Mr. Roy Abogado to lead the class prayer? In the name of the Father, Son, and the Holy Spirit.
Okay, class, before anything else, please arrange your chairs and fix your sounds. Okay, thank you.
Buoyancy. Okay, now, who can tell me or share their knowledge to class about buoyancy? Okay, I can see the hands of Mr. John Ray. Alright. Okay, that's a very comprehensive answer coming from Mr. John Ray. Anyone? Okay, Isil, do you want to add some knowledge? Or you can share to the class your knowledge about buoyancy. Okay, since everyone has a background knowledge about buoyancy, so now allow me to give you the definition of buoyancy. Gawonder ba mo why some objects float when put into the water and the others do not? Huwag mo gawonder, ana guys. Okay, the objects that sink get any support from the fluid. So the answers to all these questions and many others are based on the fact that pressure increases with depth in a fluid. Inyo ha ba ning na-observe or nabantayan ninyo ning duha ka araw? Unsa day purpose aning duha ka araw dire? So kaning nga araw nga nag-point siya pa down. This is the gravitational pull towards the center of the Earth. So, mao ni siya ang gravity nga di ba ang gravity is i-pull man ta towards the center of the Earth. So, mao ni ang iyahang purpose aning arrow nga paubos. And kaning arrow nga pataas, kani siya nga arrow, this is the buoyant force or the force exerted towards the object to prevent the object from sinking. So, mao ni siya ang ato ang buoyancy. So, imagine, no? Ang ato ating buoyancy kay siya ang murag nag-prevent nga mag-sink ta towards sa deeper ocean or mag-sink ta dito sa kanaang ilalo. So, bisan pa o ang object musink siya or mulutaw lang or half lang ang naglutaw, half ang nagsink, buoyancy is there. Bisan pag nagsink na siya sa ilaw, buoyancy is there. Dili mawala ang buoyancy sa fluid. Okay. And always remember na dili lang kaning duha kaaro diri ang forces. Naapoy forces diri sa kilid sa ato ang object. And kaning duha diri lang ta mag-focus ato sa neglect ang duha diri ka arrow. Pero naapod ni sila purpose ha. Pero mag-focus ato diri kay kaning man sila mostly ang gagawa. So this is the force 1 is equal to pressure times the area. Okay? Pressure times the area atong F1. Ang atong F2 is pressure times area, gihapon sila. And nag-wonder mo, ni nato nakuha ni nga formula, kay na-derive ni nato siya sa formula sa pressure which is force over area. Dili na nato sila nakuha. And then same na po sila, no? Dili na ako libilan para di mo maglibog. So, out of these two pressure there, we can get now the buoyancy, which is our buoyancy is equal to this. F sub 1 minus F sub 2. So, kung makuha na to ang pressure anong duha, makuha na dahil na to ang buoyant force. Kay, ang buoyancy or ang buoyant force, makuha na to sa duha ka pressure anong nila. So, in general, we can get the buoyant force out or from this equation. So the equation of the buoyant force is equal to this. Buoyant force is equal to density of the fluid times the gravity acceleration times the volume of the fluid. So this is the general form or the general equation for the buoyancy. So now, kasabot na mo sa meaning sa buoyancy. Guys, here, so this is now the definition of buoyancy. Buoyancy is an upward force exerted by a fluid to an immersed object in a gravity field. So by that phrase or this sentence, it can give us or makaingunta nga mas grabe ang force sa upward force kaysa sa downward force, no? We can say that kay ang buoyancy, iya hamang gina-prevent ang ato ang object nga mag-sink or ma-pull sa gravity towards the center of the earth. And then, if ang buoyant force is greater than the weight sa ato ang object, ang tendency ana is mulutaw or mo-float ang ato ang object. But if ang weight sa ato ang object is greater than the buoyant force, or for example, ang ato ang object is ang metal. So kung ato ang butang ang metal dito sa tubig, musink jud siya kay mas grabe man yung weight kaysa sa ato ang buoyant force. So tendency ana is that musink ang object but the buoyancy is still there. Kay remember, dili mawala ang buoyancy sa fluid. And if equal ang buoyant force ug ang weight sa ato ang object, ang tendency ana is mag-remain lang ang object kung asa siya nag-float. So, for further information about this equation, these formulas, we have Teacher Nova to fully or to thoroughly discuss all of these to you. So, please bear with her.
So class, the previous discussion with you together with Teacher Berna, she defined what is buoyant force, of course, and you have learned that buoyant force is the upward force that exerted by the fluid into a partially or fully immersed object. And of course, Teacher Berna also identified the general formula of buoyant force. So we have here the buoyant force is equal to the density of the fluid times the gravitational acceleration and multiplied to the volume of the fluid. So by the way, aha man jud daw nato inakuha nga force or aha nato ni nakuha nga equation. So this equation is influenced and derived from Archimedes' principle. So this Archimedes' principle states that any body that is completely or partially submerged in a fluid has a magnitude which is equal siya to the weight of the fluid displaced by the body. So it means nga when there is a fully or a partially immersed object, ang weight ato nga object is equal na siya sa iyahang na-displace nga fluid or liquid. So ana ang gina-state ni Archimedes. No. So we can say here that the buoyant force has the variables density, which is nasa formula nga ang density is equal to mass over volume. And then we can say here that this gravitational pull has the the constant value na 9.8 meter per second squared. And then ang kaning volume, muna siya ang ginamit ni Archimedes nga ang volume sa fluid is equal lang siya sa weight sa object nga ni-immerse. So kani siya is fluid na na-display sa object. So muna siya ang ginamit ni Archimedes. It is the volume of the fluid displaced by the object. So the easiest way to better understand the Archimedes principle is we must to use this kind of illustration in where the object is fully submerged into our fluid. So now, in the previous discussion, Teacher Berna says that there are different forces na nag-exert sa ato ang object as it submerged into the liquid. So naatay, unsa ni siya nga force diri? It is the gravitational force. And down here, it is the buoyant force, right? And then, in this illustration, I could able to let you understand, no? Nganong nakuha man yun nato ni siya nga formula. Kani. Anong mani? Unsa man ang concept behind ani nga formula. So, first, the buoyancy here is equal lang siya, no? Ang buoyancy here is equal siya sa weight sa object. No, nga weight sa object, and then katong object according to Archimedes principle, katong object nga naa pag mag-immerse or mag-down siya towards the fluid, and then when it's submerged, then there is a kanang fluid nga na displaced, no? So katong fluid nga na displaced, katong weight ato and mass ato ana is equal lang siya sa weight sa object. So say naatay buoyant force diri nga weight sa object is equal siya sa is naan siya mass sa object pod and gravitational pull, di ba? Ayan na ang formula sa weight sa object. But however, ang object is equal daw siya sa na-displace nga weight sa na-displace na fluid. So, natay weight diri sa fluid and natay M sa fluid and times G. So, now we can see that it is the formula of buoyancy. So, now, the things are not just ends here, no? Kaya kanina sa kanina siya, ang mass ni siya sa fluid nga na-displace. Okay, ang mass sa fluid nga na-displace is na siya formula, no? We can describe na to ang mass sa fluid into here. Mass ni siya sa fluid is equal to volume of the fluid times its density. So, muna siya. And then, nakuha na nato siya, ang mass of fluid is equal to volume of fluid and then its density, no? Pero, anak ko ganina, I mentioned earlier, na ang katong na-displaced nga fluid is equal siya sa weight sa object. So, we can say also na ang volume day sa fluid is kanang equal siya sa volume sa cylinder, which is ang atong object here. So, we can say that it is equal to the object, volume of the object, and its density. So, yeah, gi-equate na to ni sila, no? Ang volume sa fluid yung na-displace and its density over the volume of the object and its density. And then, we can derive also this volume, or we can describe it's also the volume of the object. So, saan mo na itong pag-derive sa volume sa object last? Ha? Sige daw, B? Isa ba yung pwede makatbag, anak? Anyone? Okay, wala pa idea ang tanan. So, this object, the volume of object, can be derived from the area of the cylinder and its height. So, magamit na to ni siya ng mga dimensions, guys. Dimensions sa cylinder. The area times the height of the cylinder. So we have here the volume of the object is equal to area times the height of the object, in where the uppermost part of the object, no, kung asa ang uppermost part sa object, dayon ang iyang distance padulong sa uppermost sa liquid. So nat mo na siya katong H1 minus na to siya sa unsa kataas ang na-submerge sa object. So here, dire siya taman. And then ang height niya from the topmost height of the fluid padulong siya sa bottom, no? Sa bottom sa na-submerged na object. So natay H2 here. So from this, now we can say na ang buoyant force can be derived from what? From the mass of the displaced fluid times na to siya sa atong gravitational force or pull. And then kani siya M fluid. O pwede na to siya ma-derive ani nga formula, which is the fluid or volume fluid times the density. Pero kay ang atong gamiton man jud the dimension is ang dimension sa tuang cylinder. So gamiton na to siya kani kay equal man silang duha. So makuha na to ang buoyant force from this equation also. No, from this equation is the fluid, volume of the object times its density. No, kaya ang M is equal to V volume times density man. So nata diri ang density. And then dili gid ato ni kalimtan ang gravitational pull. So ana. And then of course, as what we have discussed earlier, no, kaning object usa man ang iyahang mass kuan ni kanang formula, makuha na to or nakuha na to ang object, ang volume sa object is the area of the cylinder times na to siya sa to ang height. Kani mga dimensions sa object. So pwede na to di ay makuha ang buoyant force, pamaagi lang siya sa dimensions sa object, no? So naatay a density of the fluid, i-times na to siya sa height sa immersed na object, i-times din na to siya sa gravitational pull and the area. So mo ni siya. Pwede na to makuha ang buoyant force pamaagi ani nga formula. Kani sila. Pero ang the main jud na formula sa atong buoyant force ay commonly used na nga kanang formula sa force or sa buoyant force is equal to the volume of the density of the fluid times na to siya sa gravitational force and the volume of the fluid. So, sabtan na ba? Anong na-derive ni siya nga formula. So, that's how smart Archimedes, no? Kay na iyahag din ni siyang na think sa una, iyahag din ni na-calculate sa una. So, that's how smart he is. So, now I'm expecting na naka-learn mo ato, no? Kung asa man dyan nag-originate ang buoyant force. And of course, at this point, let us hear again Teacher Berna, because she will give us a sample problems to calculate buoyant force.
Okay, so now we have here sample problem on how to get buoyancy. Okay, the question is that a block of wood weighs 35 tons was thrown by a boy into the lake with the dimensions of length is equal to 6 meters, width is equal to 2.5 meters, and height is equal to 4 meters. He saw that there was spillage of water after he threw the bags. Assume that the block is now floating into the lake. Calculate the fluid that has been displaced as the bags thrown into the lake. So, ang atong gipangitaan ni is ang volume sa tubig nga nag-displace ato nga lake. So now we have the given of naatay given nga karon ato asang i-calculate ang density sa ato ang object, and it must be ang density dapat sa ato ang object kay dili siya mo-surpass sa density sa ato ang fluid, no, para mo-float siya. Mao na ang ato ang goal. Okay, naatay solution sa atong problema. So, di ba atong i-calculate ang density sa object niya, it must be less than sa density sa ato ang fluid. So, atong formula is equal to density of the object is equal to mass of the object over volume of the object. So, unsa gali ang mass ato sa atong object? Sorry, na-erase. Ang mass atong object is 35,000 kg. Ang atong volume sa object dayon katong length times width times height na di ba ta atoy 60 cubic meter. So now, ato ni ra silang i-divide. 35,000 divided by 60 is it will give us 538 kilogram per cubic meter. Remember na dapat apil ni ang ato ang mga SI units ha, dapat din nato makalimutan atong mga units. So kay na naman tay density sa object, karon atuan na dayong isolve ang volume sa atong fluid nga na-displace atong lake. So ang atong formula will be density of the fluid times volume of the fluid equal to density of the object times volume of the object. So, same lang ni silang duha. Ang ato mang gipangita is ang volume sa fluid nga na-displace. So, naatay ang atong formula from this, makaderive ta og new formula which is so, mao na ni ang ato ang bag-o nga formula. Kaning atong formula is giderive lang nato siya sa kaniang nga formula, no? So, ang atong formula now is volume of the fluid is equal to density of the object times volume of the object divided by density of the fluid. Kabantay mo, ato alang siyang gitranspose, no? Gibalhin-balhin lang nato para makuha ni nato siya. Okay, so mag-substitution na ta. Ay mag-ato na silang butang mag-value. So, pila ganito ang density sa ato ang object? Mauni ang density sa atong object, which is 538 kg per cubic meter. Times, pila man ang volume sa atong object? Mauni ang volume sa ato ang object ganiha. So, we have 60 cubic meter divided by pila man ang density sa atong fluid. So, ang density sa atong fluid, katong naa sa given, if you still remember, ang density sa atong fluid is 1,000 kg per cubic meter. So, ato lang ni silang duha i-times divided by 1,000. So, 538 kilograms per cubic meter times 60 per cubic meter divided by 1,000 kilogram per cubic meter. So, makakuha ta aning og answer na 34.98 cubic meter. So, nganong cubic meter na lang, di ba nag-ingon si ma'am nga, i-apil na to ning duha na to atong mga SI units. So, cancel na ni sila. Kung makancel na ni silang duha, unsa na malay nahabilin nga unit? Ang cubic meter. Maong naatay 34.98 cubic meter ang volume sa ato ang fluid. So, mao ni ang volume sa fluid nga na-displace sa lake. Okay? Okay. Okay, let's proceed to our question 2. A 1,500 kilogram of wood is thrown and eventually float at the surface of the water. Considering the dimensions of the block of the wood that has a height of 2 meters, length of 6.5 meters, and width of 1.5 meters, assume that the density of the water is 1,000 kilogram per cubic meter. So calculate the density of the wood and compare it to the density of the water, and then we have to find the buoyant force of the object. Okay, so we have the given here. Mass is equal to 1,500 kilograms, height 2 meters, length 3.5 meters, and width 1.5 meters, plus the density of our water, which is 1,000 kilogram per cubic meter. And the question, the A, said that calculate the density of the wood and compare it to the density of the water. And the formula of our density is equal to mass over volume. So, mo ni siya ang ato ang formula sa density. And then, from that, magbutang na din ta sa ato ang mga value. So, ang ato ang mass, diba, is 1,500 kilogram. Unsa man ang atong volume? Ang makuha na ito atong volume by adding this or multiplying this length, width, and height. So, we have 2 meters, 3.5 meters, and 1.5 meters. 1,500 kilograms divided by 2 meters, divided by kani, makakuha ta og answer nga, density is equal to 142.86 kilogram per cubic meter. Kilogram, tulungan sila ka meter, so cube na siya. Thus, the wood is expected to float on the water because it has a lower or it is less dense than the water. Diba? 142 niya. Pila man ang density sa atong water? 1,000. So, mo-float yun ang wood eventually. And then, ang ato ang B, so mauni ang atong A, mauni ang density sa ato ang wood. Sa bida yun, iyang giingon kay find the buoyant force of the object. So, di ba, previous discussion katong sa COA and then kang Teacher Nova, ang ato ang formula sa atong buoyancy is gani. Di lang basta buoyancy ni siya ha, mauni siya to gani ha. Murag ato lang siya gipangwaan og katong mga apelido para gamay lang siya. So, mauna ni siya, buoyancy. So, pila man ang ato ang density. So, ang density nato is 1,000. Ang density ni siya sa ato ang water. Kilogram per cubic meter. Times ato ang gravity. Pila man to atong gravity? 9.8 meter per second squared. And then, ato ada yung length, width, and height. We have 2 meters times 3.5 and then 1.5. As is na sila nga meters na sila ha. And then, makuha na, so ato ni silang i-multiply tulo. Kaya tanong, di ba itong pangitaon ang buoyant force? So, makakuha ta og answer nga 100 na 2,900 Newton. So, mauni ang ato ang buoyant force. So, I hope you na-gets ninyo nga inanion siya pagkuha, pagko siya kani. So, lahi-lahi man ang given, lahi-lahi man ang gipangutana, so lahi-lahi tag answer. This is the density of this is the density of the wood and this is the buoyant force.
At this point, let us solve the problem 3 about the buoyant force. So we have a problem here. A girl who passes a river was accidentally dropped her a rectangular shoebox into the water. The box has a dimension of 6 meters of its length, 4 meters of its width, and 3.5 meters of its height with a mass of 16,000 kilograms. So do you think the box would float or sink? So if the box will float, we must to calculate the buoyant force that act upon it. So to solve this problem, we must to identify first the given numbers or given dimensions that present in our problem here. So now we have given here, no, na sa tong problem. We have the mass of shoebox, which is 16,000 kilogram. We have its dimensions, no, natay dimensions therein na ang iyang length. The shoebox have a length of 6 meters, width with 4 meters, and height with 3.5 meters. And of course, at this problem, we assume that the density of the water is 1,000 kilogram cubic meter. In the first question, does the box would float or sink? So sa tuwang question A, letter A, we must satisfy or we must to determine if ang atong object mo float ba siya or mo sink siya into the water. But if ang atong galing makalculate is lesser siya kaysa sa density sa water, then the object will tend to float. But if this water, no, if this density of the object, is greater than the density of the water, then ang atong object will tend to sink. But of course, we must to calculate the density of the volume. So to calculate the density of the volume, we have a formula here na mass of the object over the volume of the object. So dali remind siya guys, kay given na tanan ang ato ang mga pangitaunon, no, nanana sila. So natay mass object which is 16,000 kilogram. So we just substitute here. And of course, sa volume sa atong object, no, when we calculate the volume of rectangular objects, we just multiply all the dimensions it have, no? So we have a length times width times height. So we have here 6 meters. It times na to siya or multiply na to siya sa 4 meters. Multiply na to siya sa 3.5 meters. So we can get a density of object. We can get the value of the density of the object as 190 kilogram per meter or cubic meter. So we must not forget the units of every value or units of every dimensions. Kay importante kayo na siya guys, no? Kay kung walay apelyido ang imuhang value, unsaon man pag-determine sa kung unsa ni siya nga dimension, o unsa ba ni siya nga kanang attribute sa ka object, so inana. So as what we have learned from Teacher Berna, na ang volume, just multiply it by the three dimensions with 3 meters. So muna cubic meter ang ato ang kuan. And of course, ang density, that is a unit of density, is kilogram per cubic meter. So, dali nakita na to, no, nga ang density sa fluid kay lesser siya kumpara sa ato ang density sa water. Tara, when we compare it, No, mas lesser kay siya, okay, 190 kilogram per cubic meter lang siya. And then ang ato ang water has a density with 1,000 kilogram per meter. So, we can conclude that the shoe box is tend to float to the water. And then the next one is calculate. So, calculate the buoyant force. So, calculate the buoyant force. So, as what we have discussed earlier, the formula of buoyant force is we have FB is equal to density of fluid times the gravitational force and multiply to the volume of fluid or object. So here. So just substitute all the givens here, no? We have a 1,000 kilogram cubic meter for the density of our fluid, which is the water, and then just times the gravitational force, which is 9.8 meter per second squared, and multiply by the dimensions of what? Dimensions of volume or the object. So, natay 6 meters times 4 meters times the 3.5 meters. So, as we put it in our calculator, we can get a buoyant force, value of buoyant force as 823,200 newtons. So this is the buoyant force, or this is the value of the buoyant force exerted, no, sa ato ang object as it thrown or dropped into the water. So I hope you get it. So now let's move on to the Ika 4 na problem, no. So in this point or problem, we base this in the problem number 3, no. So we just change the mass into 100,000 kilogram. So do you think what is the acceleration of the object as it being dropped by the girl who passes the river, no, passes and accidentally drop this rectangular object? And of course, what time does it reach the bottom of the surface as it was accidentally dropped by the girl to the 350 meter depth river? So, inani. So, na-siya ang depth ang laumon sa water sa river kay 350 meter. So, the given here is naatay 100,000 kilogram na rectangular box. And naatay dimensions niya na based sa to ang problem number 3. So, we calculate it to easily substitute later the volume. So, natay 84 cubic meters sa dimension lang sa object. And of course, naada yung taang height sa river. So, now, first, we must to identify kung ang object ba kay mo sink or mo float siya when we change the mass. No. So, we must to find the density of the object. So, we have here a formula of the density. We just substitute it by 100,000 kilogram over the volume, which we have here, the 84 cubic meter. And of course, we got the answer of 1,190 kilogram per cubic meter. And of course, we can observe here that it is much greater than the volume or the density of the water that we assumed in the problem 3. So, in the density of water, we have 1,000, no, kilogram meter cube. It is much more lesser or less than the density of the object, which is 1,190 kilogram cubic meter. So now we can say that the object will eventually sink. So we must change this, and then we must put it here na ni-sink siya. Ni-sink ang ato ang rectangular box. So ni-sink siya. Ni-sink. So to find the acceleration of the object as it will drop upon the water. So as we all know that the summation of forces act on upon the object na tayo pa downward. Natin pa downward, which is the weight ni siya sa object, no? Natay weight sa object diri. Dayon ang atuang force, ang atuang buoyant force nga upward natay ana. So now, how man nato pagkuha sa acceleration ani? So in fluid mechanics or in kinematics, no, the summation of Fy, since na ang kaning atuang buoyant force and weight naglay siya in y-axis. So, ang atong summation of forces of buoyancy is equal to dFb minus sa weight sa object. No, weight sa object na siya. Weight sa object is automatically equal to mass times A, acceleration. Mass niya siya sa object. So, muna siya ang saan na ito pagkuha sa acceleration karon. Muna siya ang formula sa pagkuha sa summation sa mga forces along y-axis. Okay, now, we must just simply derive the acceleration from here, from the formula here. So, we have a acceleration na equal to F buoyant force minus the weight of the object over the mass of the object. So, but first, wala pa man nato na-calculate kung saan bilang yung buoyant force, kung saan ito ang weight sa mass, and so, before nato makuha ang acceleration, we must to find the buoyant force and the weight by the object. So when we find the buoyant force here, okay, to find the buoyant force, we have the formula. Sabi itong formula, natay, density sa fluid, and times of the gravitational force, and the volume. Either the volume of the object or the fluid, but of course, naman tayo value sa ito ang volume sa object, then volume of the object ato dito. And just substitute the guys. We have 1,000 kilogram of cubic meters of water, natay 9.8 meter per second squared, and then natay 84 cubic meter. So natay FB na, sabi naman, FB nga, calculate sa inyong calculator. Okay, very good. We have 823,200 Newton as what we have calculated in the problem 3. And of course, how to calculate the weight of the object? Okay, right. Alright, it is just the product of mass times the gravitational pull or force. So we have it here. So just simply substitute. We have 100,000 kilogram times the 9.8 meter per second squared. So calculate the value. We have a weight of Very good. 980,000 Newton. So, muna siya. Nanatay value sa ato ang buoyant force and weight. If nanatay value, so may pwede na ito makuha. Okay. The acceleration. So, pwede na kila ito makuha ang acceleration. Ani? So, naman tayo formula, no? Dari? Oh. So, sa na ito ang buoyant force? Naatay 823,200 Newton. Minus na to siya sa ito ang weight nga 980,000 Newton. I-over na to siya sa ito ang mass nga 100,000 kilogram. So, acceleration na to due to gravity is, or the acceleration na nag-act upon pag-drop sa object is pila man? We have negative 1.568 meter per second squared. So, ano na siya? Meter per second squared. And, yan ang negative man. Yan ang negative man. Kasi maka-answer ng anong negative man. Okay. Because it is pa downward na iyahang direction. That's why we have a negative sign here. So now, we must move on to letter B to calculate the time. So in kinematics, no, we have this different formula to calculate time, velocity, height of the object or the something fluid, and then the acceleration. Do you think what is the most appropriate formula to calculate time with this just with this given lang na acceleration lang tapos na height lang sa river anak. So what is the proper appropriate formula nung pwede na ito magamit? Is it formula number 1, formula number 2, formula number 3, or formula number 4? So, okay guys, unsa man? Sa mga formula. Okay. It's number 3. Tingnan naman. Since ang atuang nako tayo sa initial velocity here. Natay initial velocity here nga 0. Ano 0 man? Kay it is from the girl man. Wala man sila naglihok or unsa na-drop from niya from na-release niya from her hands, diba? So, ang atong velocity na is equal na to siya sa 0. So, ang atong gamiton nga formula is number 3. Kay since naaman tayo x, naapot tayo velocity na siya velocity, naapot tayo ang time na to, muna siya itong ginapangita, and then naapot tayo acceleration. So naatay x equals to initial velocity times t plus 1/2 times acceleration times 2 t squared. So we just simply what do you call this? We just simply we just simply derive the formula of time. So as we can see here, initial velocity we have 0, so just cancel it. Kay 0, okay, 0 times t equals 0 Japon. And ang atong nabili na lang kay ang 1/2 times the acceleration and then the t squared. To calculate t, so we must get the t squared here and then just go to 2x over a. So to get this squared, we must square also square the 2x over a. So pila man na. So substitute lang ta. Natay 2 times 350 meters tong depth sa river over na to sa acceleration na to nga 1.568. Pauta na. Okay, nganong walay negative ang acceleration? Nga ang number 3, naman negative acceleration man to, it is because the negative is just the direction. And of course, when we get the time, there is no negative time, di ba? So, we must to remove the direction of the acceleration to get the time. Okay. So, pila man ang yung nakalculate na. So, it is natay time na 21.13 seconds. Very good. So, muna siya ang time. No? Muna siya ang time. 21 seconds ra, I have ma-reach sa rectangular or the shoebox ang depth sa or the bottom part of the river. So, that's how we calculate the time as we use this kinematics formula.
So, okay, it is important to know the concept of buoyancy because it helps us explain common phenomena such as why certain objects float and why solid objects seem to weigh less in water than on land.
So, okay class, I hope that you learned something new from us. And again, this is Teacher Nova.
And this is Teacher Berna.
And this ends our lesson. And have a great day ahead.
Thank you.